this video, we're going to take a look at the Lunar Phases lab. If you haven't already, go ahead and download the document that you'll fill out when working through the lab. And we're going to start with the readings. There's various questions in the lab that'll have you go through and read the background pages to help you answer. And then lastly, we're going to use these two flash simulations, similar to last week's lab. So there are a total of 6 background pages. You can navigate with the numbers up here at the top. Within each of these pages, there's a lot of background information. And if you take a look at your lab itself, the first part of the lab is broken down with specific pages, or specific questions that can be found on each page. So for example, on this first page, the first question is there a dark side of the moon? So you'll want to go read through the content that's here on this page to help you answer that. There are a handful of other questions about the timing of the lunar phases, as well as the names of the various phases themselves. The pictures here should help you answer those, but there are also plenty of resources online for you to reach out if you need a little bit more. On page 2, we get a little bit more in depth into the geometry of what's going on. So again, there'll be a diagram similar to this one, but slightly modified, where you will need to go through and identify where the moon would be in order for us to be able to see a specific phase on that moon. The letters that you're going to use for that part have nothing to do with the numbers on this page. They have to do with the letters on the first page. So there's A, B, C, D, E, F on the first page. They correspond to specific phases. You're going to use those letters to fill out the chart that looks similar to this diagram on the second page. You can also use the navigation down at the bottom of each page to move on to the next one. So for on page 3, this is all about the timing of things. So this is actually a little animation. You can move things around. We can change the observer. Notice when I move this, we can see the whole Earth moving. In this view, it's like you are Supergirl looking down upon the North Pole, flying high above. So where my cursor is right now, that's the North Pole. As I move this little stick person around, we can see that the local time changes. I can even click this box to make it a little bit more obvious where I need to put the person to correspond to a specific time. On page 4, we can see some more background information about rising and setting for the moon and the sky. Again, this bottom one I can animate, and so I can see how the view changes. So the little person is here. This part is the view of the sky that that person can see at any given point in time. This marks the eastern horizon. This marks the western horizon. And anything in this sort of shaded region is something that's below the horizon for that stick figure right there. If this view bothers you, seeing it this way, we can instead, I'll wait till it gets to the same position it was at a little bit before. We can instead rotate the sky, but it's important to know that this happens because Earth is moving, not because the sky is moving. So if I click the rotate sky box instead of observer, that may make it look more like what you would actually see if you were on Earth, so that's a more familiar view. But again, it is actually Earth moving, not the sky. There are 2 more background pages. On background page 5, we'll come back to the horizon diagram. We saw this in the Sky Motion lab. So now, in addition to having the sun, we also have the moon. So again, I can move my horizon diagram around to change its orientation and see things at different positions to help me understand. And then the very last one is page 6. This is the last of the background pages before we get to the actual big simulations. So this shows collectively 3 different views. so that you can see how they all connect together. Now, once you're done with the background questions, which finish on page 3, you'll get to page 4. On page 4, you're going to go through and essentially follow the directions and make a prediction, and then go through and use the moon bisector demo. So that's the very first of the 2 simulations. That looks like this. You'll use this moon bisector demo to check your answer to the above problem. Feel free to go through and correct your answer if you didn't get it right the first time on your prediction. But in this particular one, we can go through and add shadows, show the direction of the sunlight. We can add some bisectors. We can show shadows. We can add lines between things. We can change the position of the sun to be different places and see how the moon phase changes based on that. You can also go through and change the moon itself. So you'll use this to verify if what you drew is correct. You can also change the perspectives if you'd rather, between what you would see on Earth versus if you were sort of a superhero flying above. The bulk of the lab from this point forward will use the second of the 2 phases, of the 2 simulations. So this simulation combines a lot of the things that we saw in the background pages all together into one view. So we can do a lot of moving around here as well. So this main panel right here shows the sunlight coming in from this direction. That means the sun is over here in this direction. It shows the Earth, and again we have our little exaggerated stick figure that we can move around. And it has the moon, which again we can move around. Now this is definitely not to scale, but it's useful enough for our purposes. So I can move the moon, I can move the person on my Earth, and all of these change things in my other diagrams. In this diagram, it shows the moon phase based on the position of the sun, the moon, and the Earth. You'll notice that if I change the location of the person on the Earth, it does not change the moon phase. I can change the location of the moon. That does change the moon phase. If you want to go to a specific one, you can go ahead and click it. Keep in mind that new moon, first quarter, full moon, and third quarter happen on exact days, and the waning crescent, waning gibbous, waxing gibbous, and waxing crescent happen over a variety of days. So if I start, for example, on new moon, I can take a look at first quarter. I can see the position change. Any location I put the moon in between those 2 is all going to be listed as waxing crescent. It's just different amounts lit up, different percentages you can see. The horizon diagram will show me where the sun and where the moon is based on my little person here, which is based on the time. So if I change this little person around here, I change the time, which we can see also changes the location of those things. I can animate this and see how it changes over the course of a day and night, on and on and on. I can change the animation rate. I can increment it by a day, an hour, or even a minute. And I've got some diagram options, so I can look at the angle between the moon's current location and when it's new moon. I can add some landmarks in there. I can show some time tick marks, whatever I need to go through and answer the questions. I can also hide some of these diagrams if I want to. So you're going to use this final simulation to go through and answer the last questions on pages 5 through 9. Some of the questions will give you specific instructions on what you should be going through and doing. For example, dragging the moon around until you get to a specific place, turning the angle on, seeing how that changes. Page 6 is going to be filling out a large table. So it is giving you a view in the very first column that shows where the sunlight should be coming from, where the Earth is. That's the blue circle on your lab, and the gray circle is the moon. You'll notice the sunlight is not always coming in from the same direction. So you can, if you're using an actual piece of paper printed out, I would rotate your picture to be able to have the sunlight in the same orientation as the simulation. Alternatively, if you're using just a screen, try and lock your aspect ratio and move your screen around too until they match. Once you get the right moon geometry, you should be able to read off of here for the moon phase, here for the percent illumination, and then do a rough sketch of what you're seeing. In your sketches, the dark parts correspond to the places of the moon that are not receiving light, whereas the light part corresponds to the part of the moon that's being illuminated. So in the following pages, you'll go through and look at rising, setting, and meridian times, similar to what we did in the Sky Motion Lab. Again, that corresponds mostly to the horizon diagram. And so you can go through and see when the moon sets would be when it's in the western horizon. The meridian, again, is this line right here. And then rising corresponds to when the moon is on the eastern horizon. And you can record the times right down here. They give you an example so that you can go through and make sure that you're doing everything correctly. On page 7, you're going to be giving another table where you're given 2 out of 3 items. The time of the observation, the phase of the observation, and the location of the moon at that particular observation. So, again, you're given 2 out of the 3. So you will either need to, if we're looking at the row A here, if it says the time is noon, I can turn on my time tick marks. And I need to move my person until it gets to noon. It says the phase is first quarter, so I'll select first quarter. And now I'm going to record from the horizon diagram where I would see that moon. So in some of the instances, you're given the time and the phase, and you have to find the location. In some of them, you're given the phase and the location, and you have to find the time. So in that case, you'd select the phase, you would move the moon around to the correct location, and then you would look at the time. And then lastly, you can have an option where you're given the time and location, and you have to determine the phase. So again, if you know the time, you can move your person. If you know the location, you can go through and move that as well. And then you can go through and figure out what phase that must need to be in order for you to be able to see it at that particular location. The last page has 2 summary questions, again, using this horizon diagram here. So remember, you can move it around to whatever orientation you need for that particular view to answer the particular question that you're being given, to try and assist you with your understanding of the lunar phases. Feel free to reach out to me on Slack if you've got any questions, or come by office hours, and I'm happy to share my screen and we can walk through something if you're having trouble figuring out the controls.